Alright, ladies and gents, hopefully this is the last video that I need to make in a while. My name is Miss P, you know that. Anyway, I'm just going to introduce your water molecules just for a second so you know what's going on today. During your lab, you'll want to make sure that you're efficient in your lab because you will run out of time, and today is the only day that you have to do this, so get it done. So the first question is, what do these have in common? You will notice that they all have an oxygen and two hydrogens. Oxygen, two hydrogens, oxygen, two hydrogens. So they're all water molecules, meaning they have the same properties, X, Y, and Z. They're just different ways to diagram them. So, we talked about polarity a little bit, but just to jog your memory. Polarity would mean like you have poles. So you could think like the magnet has a north pole and a south pole. Water has a north pole, meaning the hydrogens, and a south pole, meaning the oxygen. And the reason why is because they have a partial positive and a partial negative, because they share the electrons unequally. Please remember, electrons have a negative charge, so they're going to end up being a little closer to the oxygen atoms. So like here's, if these are connected actually, right? The electron would maybe be here, not quite in the middle, closer to that oxygen. And since they have a negative charge, you get the two negative charges on the oxygen side, the two positive charges on the hydrogen side. Hopefully that makes sense. So here you can see again, partial positive for the hydrogen atoms, partial negative for the oxygen atom, right? This is how we denote partial, is by the little delta sign. So delta negative would be negative, delta positive would be partial positive. Slight positive, slight negative, we're good. Now, that is within one water molecule, this right here. So, we just said they're covalent bonds that connect inside the molecule. So there's covalent inside. Now, what about this water molecule to the next water molecule? That is hydrogen bonds. So this water molecule, oxygen, that has a slight negative, is attracted to this hydrogen part of this next water molecule that has a slight positive. So the slight interaction between the negatives and positives are made by a hydrogen bond, but they're really weak. They can easily be broken. Ionic bonds are something different. Ionic bonds are when you transfer something. So, hold on, I'll be right back. So, in your little water molecule kit, you'll have a sodium and a hydroxide, or a chloride. So, Na and Cl. So this is Na, the blue, Cl is the green. And they stick together, right? So that means that they have some sort of bond. Their bond is ionic because, if you remember, sodium doesn't want this electron right here, and chlorine does. It's actually missing one right here. So it wants this electron. So because the electron transfers, then it's an ionic bond. Ionic bonds aren't terribly strong. Covalent bonds are much stronger. So when you use these little guys, you pull them apart, put them together again, chlorine and sodium. They also attach to water, right? So here's my little water molecule right here. You'll notice that the chlorine will be attracted to one part of the water molecule, and you'll notice that sodium will be attracted to a different part of the water molecule. And that's because of the charges, right? Think about the charge of chlorine, think about the charge of sodium, and then think about the partial positives and negative charges of the water molecule that we just talked about. Okay, then we move on to covalent. So we already talked about that they're sharing electrons inside. So this is a covalent bond, and this is a polar covalent bond because it has a partial charge, right? Now inside your little baggies, you also have 3 carbons on the bottom, 3 carbons on the top. This is called ethane. And ethane is also a covalent bond. They share electrons. But this one happens to be nonpolar. It's not charged, meaning they share the electrons right in the middle of the molecule itself. So when you try to mix a nonpolar thing like this and a polar thing like this, you'll notice they magically don't stick together. Because remember, likes dissolve likes. So nonpolar stuff interacts with other nonpolar stuff, and polar stuff interacts with other nonpolar stuff, but they don't interact with each other. So if I take another water molecule that's also polar, they will have an interaction, right? Polar and polar. But polar and nonpolar don't have an interaction. All right. Covalent bonds, whether they're in this form, nonpolar, or in this form, polar, they're really, really strong. All right. Last thing, cohesion and adhesion. So cohesion is between two like molecules. So two water molecules being attracted to each other, like right here, that's cohesion. Adhesion is two unlike molecules. So between something like a water molecule and a different molecule, that would be adhesion. We already talked about that, but just to re-put that in your brain. Good luck, have fun. Oh, one more thing. At some point you're going to have to make ethanol, and let me show you how to do that. You take your ethane, which has 6. It may actually have 5, and it might be missing one. Just pretend like a 6th one is there. The reason why it's missing one is because you have to make ethanol. So how you make ethanol, this is ethane, if it had a white one right here. To make ethanol, take a water, pop off one of the white hydrogens. Girls, you might need to help some guys because you need a fingernail. And you're going to attach this ethanol to the ethane by just sticking it in the hole. So now you have what looks like a little puppy, right? This might have different properties now than ethane because now it has a hydroxide group on it. So now if you try to stick it to water, it might do something different. So this is ethanol, OL. When you pull this off, that's ethane. Again, please remember that the hydrogen is missing here, but it actually should be there. All right, good luck, have fun, get this done this hour, go.